Alright, so we're still working through 1.3. So today we're going to look at graphs of functions and talk a little bit about that and find the domains and ranges of graphs of functions. Alright, first, there are three ways to represent a function. Verbal representation, which typically is an application type where they give you a description, or you give it a table of information and you can see the relationship between the x and y values like we did with the thunder example. Numerical representation, again, where you have a table of values. Symbols, which is the function itself, or a graph. All right, you can plot your points and connect the dots. All right, that's what a graph is. And so the four representations. So symbolic is the function. Numerical would be setting up a table of values where you pick x values and you find the corresponding y values. These correspond to points, right? We have the point -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. And those are the points that we use to graph. So we plot those points, like a scatter plot, plot those points, except it's not scattered this time. They have definition and shape. All right, we plot them to get the shape of the function, and then we connect the dots and we'll see the shape. So this particular graph, the shape is a parabola opening up, right, where we've plotted those points and we've connected them with the blue line, and there's my graph. The verbal description describes what the function is. So the function is our input value x is squared. So the first thing we do is square our input value. Then we add 1 to it, and we'll get one output value after that. We're going to do more examples where we'll walk through and we'll give you symbolic, we'll find numerical, graphic, and we'll describe it verbally. Later on, we're going to look at the graph. So we're going to kind of focus on the graph right now. The graphical representation of functions in terms of, again, corresponding with domains and range, or domains that we talked about, and adding to it ranges today in this set of notes. Alright, so graphically, domain and range. So remember, the domain of the function is the set of all x coordinates, x values. So in a graph, it's the coordinates, the x values of the function. The range is then the y, the outputs, the y values. So all the y coordinates of my graph. Alright, so that's the graphical definition of domain of a function range. Alright, so we've got the graph of the square root, and I'm going to go through how to find this also by hand, which is what we practiced last time. But I'm going to first graph and then we'll look at it by hand. Alright, so before we get to the domain, so here's my graph of this function. Alright, so we've got the graph of the square root of x minus 2. So there is the symbolic, there's the graphical representation. So the first question is find f of 1 and f of 6, and then we'll get to domain and range. Alright, so f of 1 first. So f of 1, so remember, that's my x value 1. I plug into my function and see what my y value that's paired with it. So I plug 1 in for x, so I get square root of 1 minus 2. So 1 minus 2 is -1, which is not real. Remember, back in the definition I said if you get a non-real number out, what we say is f of 1 is undefined. It does not exist in the real numbers, right? Therefore it is undefined. And if you go up here in your graph and you look, so now we'll look at the graph. Here is 1, right? There's x equals 1. If you look at it, at 1, there's no function, right? The function starts over here at 2. And so there is no one value that's mapped onto my function, right? If I plug 1 in, there is no function value to pair with it. There's no y value that corresponds to it. And so in that case, we just say, well, if that happens, no real numbers, undefined, not in my domain, right? 1 is not in the domain. All right, now look at the other one. All right, so now f of 6. All right, so f of 6. So x is the 6 value, square root of 6 minus 2. So what's the y value? Square root of 6 minus 2 is 4. Square root of 4 is 2. And so my x value is 6. The y value that's paired with it is, so f of 6 equals 2, and that corresponds to the point. X is 6, y is 2, right? The x value is the 6. The function value, which represents the y, is 2. And if you go look at the graph, that is the case. So here's my 6, there's my x value is 6, and I go look at the graph. Well, it is paired with the y value 2, right? It is this point to 6, which represents the function value at 6, is 2. Right? When I plug 6 in for x, I get 2 out for y. Right, now the domain and range. I'm actually going to write them up here, right? So the next question is find the domain and range, use set builder notation and interval notation. So I'm going to talk about them up here. So my domain first. Remember, the domain is the x values, all of the x coordinates that map onto my function. So if I look at my function here in blue, my function starts at 2, and then this arrow means it's going off for forever. And so all of the x values that are on my function, all of the points that have x values on my function start at 2, and then they go forever. Right? They shoot off to infinity. And so the domain, if I use interval notation, is starts at 2, goes off to infinity. At infinity we put parentheses, but at 2 that point is solid there, it exists, and so that would be brackets. Using set notation, it's every x such that x is 2 or bigger, right? X is greater than or equal to 2. And there's my domain. All right, now my range would be looking at the y's, right? My range. I'm going to give myself more room to write. All right, so now the range, right? The range is the set of y coordinates. So my range are the y values, the y coordinates. And so I'm going to look on the y part. And so the y part, this is the y-axis. So the function starts here, right? This is where it starts. And so it starts here at 0 in the y direction. And then the function is going for forever. So that means the y values that can go on to my function also shoot up for forever. And so 0, right? I start at the point 2, 0. X value 2, y value 0, that's my starting point. And then the y values, since this is going off for forever, the y values are increasing forever. They get bigger and bigger and bigger as I move down that function. And so it goes from 0 to infinity, including 0. Right, that's the interval notation. The set notation would be all of the y values. I'm going to erase so it looks a little neater when I write it out. Alright, so all of the y values, set notation, every y value such that y is greater than or equal to 0, right? That's the range. It's the y values. It's all real number y values such that, this line means such that, the y values are positive and 0, right? 0 is included, so I put bracket at 0. It is included. It is the starting value of my, starting y value of my function. Alright, so domain and range graphically. So just another couple of examples, we're going to do the same thing, alright? So these might be slightly out of order because the way it moves things around when I move it to this. So I think it is slightly out of order. I believe this is B, and then we'll get to A, and then C. So just be aware of that. There's A on your notes, B on your notes. Alright, so this is my function. Alright, so this is my x-axis, this is my y-axis. And so looking at this is actually a cubic, in case you should know kind of the shape of this graph, so it'll be a cube function. Alright, what is my domain? And we want interval notation. And what is my range? Alright, so the domain, if you look at it, domain is my x values. Well, my function, this means it's going on forever, and this means it's going on forever. And so the range, or not the range, the domain is all reals. And as it turns out, so is the range, right? If I look at my function, these are my y values. Well, if you look at it, the function maps over those y values, right? All of the function values here has y values shooting up for forever in both directions, going off to negative infinity and positive infinity. Same thing's true for the x values. And so the answer to both of them, domain and range, is all reals with interval notation. That means everything from negative infinity to infinity exists on this function in both the x direction and the y direction. So I can plug anything between negative infinity and positive infinity in, and it's on my function. And I get out everything between positive infinity. All my outputs also include my infinities and my negative infinities. Alright, the second problem, which is actually the first problem on your sheet, and again, the program doesn't put arrows in it, but that means shooting off for forever. Alright, so there's my function. This is my x-axis. This is my y-axis. So the first thing is the x-axis. If you look, my x values map on, and these arrows means it's going for forever, right? Everywhere here it's going to go off to infinity in that direction. My x values. And negative infinity, because again, this goes off for forever. And so my domain is all reals again. Negative infinity to positive. Alright, everywhere I can plug any number I want in here. There's no holes, gaps, or asymptotes. It starts and goes off to for infinity and negative infinity. My range, however, that's not the case. Alright, remember the range is the y value. So if I look at my y values, this is where the function starts in terms of the y, right? It doesn't exist below that. And so my function is existing up above that, and so the y values that come off of my function have to stay above this lowest point. Alright, so what is that lowest point? Alright, well that lowest point is 0, 2, and so the y value of 2 is where we start. And then we do shoot off for forever. Right? It goes 2 for forever on this function. Keep messing up my infinity. Alright, shooting up. So my range starts at 2, and it does exist at that point. Right? The y value it starts at is 2. And then shoots off for forever in the y direction. Alright, there are 2 to infinity is my range. So I don't get anything less than 2 out of this function. All of my y values below 2 are not a part of the range, right? The function doesn't exist down here for these y values. It only exists up here. Alright, the last one, which again is a lot like our first... Oh, this isn't the last one. There's one after this. It's a lot like our first example. This would be a square root function. Alright, so this would be where it starts, and it does shoot up forever in this direction. Alright, so I'm going to write out the starting point. So 2, 0. And so the x's, so again, same thing. My x values, I start here, and then all of these x values map onto my function. And so my domain well, I start at the x value 2, right? This is the x value 2. And then I'm going off in this direction, so that means I'm shooting off to negative infinity. So my domain is negative infinity up to 2, and it does start at 2, so I include 2. And so there's my domain. My range, which is the y values, well, the y values, again, start here at 0, right? This is where my y values start. And then, again, it's slow, but it is shooting up forever. All of these are going to go on for forever. And so it is going off to infinity. It is growing on this end. So my y value is 0 to infinity. 0 is included because that is the y value we start at, right? It starts at 0. And then since this is growing in that direction, I am shooting off to infinity. So my range, my y values are all y values 0 or bigger. Right? 0 to infinity. My domain are all x values 2 or less, right? 2 or less. Now the last one. So this is the last thing. So this one is starting and stopping. It's a piece of a circle is what it is. Alright, so I start here. And if you'll notice, that's an open circle. Alright, open circle. And then this is a closed circle. And so it starts here at the point -1, 3. And then stops here at the point 1, 2, 3, 4. Alright, whatever that would be. So it's at 4... 1, 2, 3, 4, 1, 2, 3, 4, 5, 5, 5. I'm going to say 5.1. Alright, somewhere around there. Alright, so domain first. Alright, so domain are my x values. So again, my x values kind of start here, but you've got to keep in mind it's an open circle and then stop there. Alright, so be careful with this one. My domain is only starting here at -1, my x value -1, and stopping at my x value 4. But remember, this is an open circle, so that's my starting point, but I don't exist until after that starting point. And so when I write this down in my domain, at -1 I start, but I don't exist at -1, so -1 is not in my domain. Now, I do stop at 4, and since it's a closed point, 4 is included. And so the domain goes from -1 and everything in between it to 4. 4 is included because it's closed. -1 is not included because it's open. and so we put a parenthesis there. All right, and keep the same thing in mind when I do my range. All right, so remember the range is the y values, and so it's the values my function goes vertically, and so that would be where my y value, and then I go up to where my biggest y value, it's not this end point, my biggest y value, right, my entire function lands between whatever that y value is and whatever that starting point is. And so it doesn't have to do with my end point, because I actually hit this y value up here. Alright, so this would be the biggest y value, this would be the smallest y value. Alright, so the smallest y value is 3. The biggest y value is 1, 2, 3, 4, 5, 6. And so my range goes between, so my function, right, exists between the y values 3 and 6. And same thing, it exists at 6 because it is a part of my curve here at 6, but it doesn't exist at 3 because that's an open circle. So parentheses at 3, bracket at 6, right, and that's my range, all right, where my function exists, so my range in that case. All right, so we'll stop there. And we're going to pick up a little bit about the graphing calculator in the next set of notes. So again, that's graphically, and we'll come back to the 4 ways you can represent a function. We'll talk about that after we talk about the graphing calculator, so we're going to stop there.